All right, nice, easy part here. Go grab a calculator, hit pause if you don't have one with you. Go grab a calculator. It says if necessary. So, evaluate each log. If there's a base 10, you can use a calculator. You know there's a base 10 if there's something missing. So in this first example, there was no base, so that's implied that there's a 10 there. So grab your calculator, type log, find the button that says log, and then just type a 12 after it. We're going to round to the nearest hundredth, so that's 2 decimal places, and make sure you round correctly, but you should get 1.08. For B, notice there's an ln. You should see an ln button. So type the ln button, hit 0.75, and you should get negative 0.29. Again, make sure you round correctly. On C, you can't type this into the calculator because it's a base of 3. But notice that those are the same. If you want, you could even set it equal to x, change it to exponential form. Always put a 1 exponent if there's nothing there. So in this one, it's equal to 1. For D, there's ln. So hit your ln button. You're going to have to be a little careful when you do this. ln, when you type the e, remember it always gives you that exponent. You're going to have to put something there. Go ahead and just put a 1 there. You will notice when you type that into the calculator will tell you 1. The reason it does that is because there's actually a base of e there. So if those bases are the same, it's going to equal 1. And then the last one, we've had this one a few times now. I guess I like 7. If you set this equal to x, 7 to the x power is equal to 1. Again, you need to come up with something. 7 to some power, that's going to give you 1, so it's 0. So this is 0. X is equal to 0. All right. Inverse properties of logarithms and exponents. All right, so log base b of b, so pretty much I'm just trying to emphasize that those are the same. Raised to, I don't know, the nth power, this is going to equal n. So if these are the same, those will pretty much all just cancel out and it'll equal the n. And I'll show you some examples with this. Another property here is if you have a base, I'm going to make that kind of big, and then this will look weird, but let's say that you have log up in the exponent, and the base of that log is b of n. Again, notice here that this base and this base are the same. Then it's just going to equal n. All right, let's try some of these. So those are just kind of like definitions here. Take a look at this first example. Log base 3 of 3. Do you see how those are the same? Log base 3 of 3. Since those are the same, this is going to simplify to 11x. If that bothers you, if they're just like, what the heck, where is she coming up with that? You can always, let me erase that a little bit. Let me set it equal to, I don't know, y for now, just because there's already an x there. And let's just change that to exponential form. So if I have the base is 3 raised to the y power, remember we're solving for y this time, equals 3 to the 11x. Well, notice your bases are the same, so y, that's what we're solving for, is just 11x. But why do work if you can just write down the answer? All right, same thing here again. We have a base of 5 and an exponent with log with a base of 5. This is just going to equal 10. All right, if you look at C, you'll notice that there's an 81. That's not very helpful, especially when the base is 3. Let's see if we can break up that 81 and rewrite it as 3 to some power. So that's 9 times 9, 3, 3, 3, 3. So 3 to the 4th power is 81. If I rewrite this as log base 3, 81 is really 3 to the 4th. Look here, these are the same. So your answer is going to be 4. And you're done. One more. We've got a base of 5. Let's rewrite 25 so that it's a base of 5. So 5 squared is 25. There's already an x up in the exponent. My base and that number are the same. So my answer is just 2x. So not a lot of work to do if you can get those matched up. Alright, finding inverses. Remember, inverse means switch x and y, which is the first thing we're going to write here. Switch x and y. First step. Then change to the other form, meaning either go exponential or logarithmic. The next thing we're going to do is solve for the new y, and then if necessary, go ahead and simplify. Alright, so step 1, switch x and y. So I'm going to change the y to an x, and I'm going to change the x to a y. I'm kind of stuck now, so I'm going to try to change it to my other form. So right now this is exponential form. There's an exponent. So I'm going to write log. The base is always whatever has an exponent, so that's a 6. Log base 6 of x equals the exponent y. My goal was to get the new y by itself. I did that. So now I'm just going to remember to write it fancy. Y to the negative 1, or f to the negative 1 of x, equals log base 6 of x. Let's try another one. Remember, first step is to change x and y. So x is equal to the natural log of y plus 3. Alright, I need to get y by itself. Right now I'm kind of stuck. You cannot subtract the 3 because that 3 is connected to the y right there. So you cannot subtract it. You're kind of stuck. But there is an e there. So I can rewrite this as e to the x power is equal to y plus 3. So that natural log is gone. To get y by itself, just subtract 3 from both sides. And I'm left with y is by itself, so I'm going to write y to the negative 1 is equal to e to the x minus 3. Remember that y to the negative 1 is just showing you that this is the inverse. Notice that the inverse from the original problem to the answer, one's always in log form and one's always in exponential form, which is why logs and exponents are inverses of each other. A couple more, then we're done. Switch x and y. So I'm going to change the y to an x equals 2 to the y power over 3 and then minus 3. I'm going to go ahead and add 3 to both sides. So I've got x plus 3 is equal to this ugly fraction 2 to the y power over 3. Just doing some algebra here. I'm going to go ahead and multiply both sides by 3. I'm going to have to put parentheses over on the left. I can go ahead and distribute here. So I have 3x. Alright, I lied. I'm going to back this up. I just looked at the original problem a little bit more closely. Okay, my fault. I should have, in this original problem, I really should have put parentheses around this. I wanted all of that 2/3 to be to the x power. So, sorry about that. Let's back it up to here. Hopefully you guys weren't working in pen. Alright, you can still go ahead and add the 3 to both sides. So I've got x plus 3 is equal to 2/3, all of that to the y power. So I can't multiply both sides by 3. I'm stuck. I have a variable in the exponent, so I'm going to have to change this to log form. So log, the base is actually a fraction. It's 2/3 of all of this stuff. So I'm going to have to put parentheses around that. X plus 3 is equal to y. I'm done. I've got y by itself. I can just put my little -1 and I'm done. make sure you've got these parentheses right here. It would be incorrect if you didn't have those parentheses. Alright, last problem. First step, change your x and your y. So x equals 3 plus log y. Maybe you want to fill in the base because it's not there, so it means it's a base 10. Alright, we're trying to get y by itself. I can subtract this 3. So I've got x minus 3 is equal to log base 10 of y. To get the y by itself, I've got to change it to exponential form. So start with the base, which is a 10, raised to the x minus 3 power. If you want to put parentheses around that, you can. It's not necessary since it's all up in the exponent. But then that would be equal to y. You now have your y by itself. Your answer, 10 to the x minus 3 power. Alright, go ahead and try the lesson in Buzz, see how you do. Any questions, please make sure you make some notes, and we will talk in class.